Welcome. Let us talk about polymorphism, and this is the third most important pillar of object-oriented programming. So far you have seen that when we do inheritance, we have a superclass and subclass, and now when you are talking about the change of behavior from the superclass and the subclass, we are talking about overriding, but that's actually where polymorphism comes into the picture. Polymorphism means, poly means more than one form, morphic is form. So more than one form is polymorphism. So let us talk about polymorphism. Java supports polymorphism, and the use of polymorphism, it makes your program very easy to extend and add different functionality. And to illustrate the concept of polymorphism, we'll actually look at an example. Look, there are different types of animals here, and you can see we have starts from bird to frog to lion to horse, and what we see, we are talking about move. When we say move, everyone has a different types of movement. You see, jumping, frog is one by one, and the horse and the bird, they have different types of move. You see, frog is jump when you call move. When you call again move for the horse, you see what happens. Horse is having a different type of movement. And when you say this particular bird, you say move, it flies. So same move but has a different types of interface. So polymorphic means ability to be in many form or shapes. That means you have a behavior called move in the parent. All childs has different behavior for same move, and this is called polymorphic. So it's an object's ability to decide what method to apply itself depending on where it is in the inheritance hierarchy. So what happens, it allows a single variable to refer to object of different class. Look at this, an example. Inheritance hierarchy, that means if you have to have a polymorphism, you must have inheritance and you must have overriding. So what you see, shape has a display method, and rectangle is a shape, pentagon is a shape, triangle is a shape. They are all child. Everyone has a display method, and these are actually further child of rectangle, square, isosceles triangle, and equilateral triangle. There are different types of triangle. They are all different childs of triangle. What you see now, that in shape I have this display method, and the same display when I write for rectangle I override, and I override all display methods, and every display is different from every child. So the shape class defines the display method, and the method is overridden in the rectangle class, and so on. So all the methods are overridden in different classes, but the method name is same but the behavior is different. So what you see now, you are testing, so you create an array of shapes and assign different shapes. One is a square shape of 0, one is a new triangle, and you're looping and calling in the loop shape of I, because shape is actually, you remember, shape actually is the superclass, and you are actually assigning different object to superclass, and by calling the display, it understands which display to call. Like for example, calling display will call the display of a square, the display of isosceles triangle, and the display of pentagon. So polymorphism, the display method execute depends on the actual type of receiver object. Alright, so program needs to test this actual type of receiver object to determine the method to be executed. And the result is a simpler code. So polymorphism, the display method will be executed for shapes of I. I is the index which is changing from 0, 1, 0 representing rectangle, 1 representing a triangle, and so on, and calling its respective display method. For example, you can see here, this is actually the shapes. These are actually array of pointers, you can understand, and you are calling the display method of different objects, and different objects display has different behavior. So this method is called, when you are calling the rectangle display, you are calling the display of triangle, and so automatically it identifies which method to call. You see, automatically it identifies that method to call, and it's going one by one and calling different methods. So this is actually the outcome of polymorphism, and an object ability to decide what method to apply itself depending on where it is in the inheritance, and we understand that now. Just extend the hierarchy. You can have further extending hexagon has a display method, and you can write for it. Hexagon is a subclass of shape, and you can have another polymorphic, but you can understand that you are adding different shapes and you are actually calling the same methods. So there is no need to modify the statement in order to, because you are not changing, you are only adding class and changing the index, and the same method call is working. This is an example of animal clinic. You can see animal. This is actually animal superclass, and it has a name, and it's hungry type of data member, and it has methods constructed and introduce self, eat, get name, get sound. Then cat and tiger actually is an animal, they are subclass, and you can add your own attribute and also the methods. So this is an example of an animal class. You have two property, and this is your constructor. And then introduce self is a kind of method. You just display, you say hungry or you full, eat, that's kind of method. And then animal clinic, you are actually creating animal clinic. Animal clinic has many animals, so it's an array of animals. An animal clinic, you put the number of cages and then create this many objects, and then initialize every object with null, and then list animals, feed animals, add animals, and you can do all polymorphic stuffs. Alright, so compile and run the program and you see the output. So this is another example, vehicle, car and bus, and you can actually define the polymorphic behavior of this hierarchy. So what you have, this is a class vehicle, you have gear and speed is a public property, but we know we do not make any property public. Car is a child of vehicle, and same, we write different methods. Super dot print description, you can understand we are calling the print description method of the super class, that means class vehicle. And same super dot print description, that means print description is a method which we call from different class, and we execute the code and we have this output. So this is actually the first part of the polymorphic discussion. I hope enjoyed the object-oriented programming, and polymorphism is a real life object-oriented programming.